So let's start. Last week I've been reviewing Xuan PR and the one from Riddick, and also discussed the first one with Xuan and Riddick respectively. And I also sent a mail to the team for further discussion on the ordering in Futurized Store. And that's me, Treme.
I provide a SeaStore or proof counter PR and damp proof counter PR. And I'm currently reviewing Sam's PR. That's all.
Greg, anything you want to share with us?
This is the first thing I've done. Thank you, though. Oh, oops. I said no, this is the first thing I've done. Thank you, though.
Oh. Riddick.
Since last week, mostly I was working on in classical OSD around the Segfoot handler. However, for Crimson, actually I'm still working on small optimization related to replication. Here it is. The idea is about optimizing latency by crafting the replication messages first, ensuring that the replication related messages rep-ops are crafted and sent first, and then actually sending the request to local store. Similar algorithm is being used in classical OSD. In Crimson, the arrangement could be in some cases. Okay, mostly we wait on local store, which could increase latency. Apart from that, the Crimson backend, I'm sniffing around thread pool loop where a segment was observed in Alien Store. That's me.
Hi, everybody. First, there are two PRs. I remind you that if anybody has time to read and review, two PRs that actually change classic OSD Scrub on the way to have a matching Crimson implementation. That's first. I'm now working on testing what I wrote for Scrub backend part, the part that checks, that actually compares objects, compares snaps, etc. I'm testing what I wrote as part of Classic, but the code, apart from the snap parts, which does not exist, wouldn't work in Crimson, I understand for yet, is the same. That's it more or less.
Are you testing using a Vista cluster or using the topology-based test?
The two PRs that are ready were tested extensively in tautology. Extensively, actually, I exaggerate. Remove the word extensively. Were tested as much as I could with my priority, with the priority I used there. I found a couple of bugs that were fixed, and now I think it's ready.
Okay, I was wondering if I could pull it into my test batch. So it had been tested, so never mind.
No, you should. I think you should. It will. I think it's better to have the full. I ran small groups we filtered with either thrashing or scrub. This is usually what I'm using. but I didn't run the full suit on weather suit on. So
Will do.
Yeah, thanks.
Thank you. Sam?
Yep, I put out a PR that fires up SeaStore to the point where it can boot an OSD and even complete a couple of IOs before crash. Progress of the sort. I'm reviewing Jim's PR and a few other reviews. That's it.
Sorry, I was working on the design of the interface of a block device mapper, which is supposed to be to serve as a proxy layer between the SeaStore's transaction manager and segments or random block managers. Here's the link of the documentation. I expect that many modifications might be needed to be done in the document. Looking forward to your reviews. Thank you.
By the way, the document requires access. I will request it.
Oh, sorry. Okay. I think okay. I've shared with you guys, and you should be able to see it.
Now I can see it.
Anything else?
Nope, I think that's it. As far as the SeaStore thing you asked about, Kifu, the assumption is that when due transaction returns, the operation is already sequenced.
I see. Thank you. So we still need to return two futures.
Wait, why?
If you really want.
I'm saying that
yes.
If you submit two things to due transaction, they will complete in the order in which you submitted them.
Yes, by two futures, I mean one is the interface which we are using for sending a request down to when serving a client request. We chain a bunch of continuations, right?
Sure.
One of them, to be specific, when performing a mutation to the cluster, to an object to be specific, we need to wait for. Typically, we need to wait for three futures. One is the one sent to object store. The other two are sent to the replicas.
One to the object store, and then n to however many replicas need to process the request. That's correct?
Yeah. Yes. We do this in parallel.
Yep.
But we could have a more multi-parallelism if we don't need to wait for the three of them, just wait for the first of them and continue on with the next request.
You should be able to do that. Just code up the pipeline so that it'll permit multiple of them to be in that state at once. I already did that once in SeaStore.
But this would need to restructure the
pipeline. Yes, you'd have to change the pipeline state code. I already added a state that does that. It's concurrent ordered state or something. I can't remember what I called it. I added it for SeaStore.
I recall that. Okay. We'll see. anyway. Do you have any comments regarding to this design? I think you added two more phases in the PG pipeline to facilitate the parallelism when processing the request.
I think no. I don't have any more comments on it.
Okay. Probably we could leverage the parallelized pipeline created by Sam in SeaStore to make this happen instead of using the callback, which I'm not really excited about.
Okay.
Sorry, what was that?
Because if you look into the PR, I was referencing in the mail 39772, where Xuehan introduced he does two things. One is to introduce another two stages in the pipeline, PG pipeline. Another thing is to pass down a callback down to the object store to get notified when the object store accepts the request.
No, in general, we should just ensure that the object store interfaces do that correctly in the first place. We shouldn't need a separate. We shouldn't need a separate callback for that. Like the object store internally can just make sure that anything that gets queued has its ordering respected all the way through the process. Why wouldn't we make that true as soon as due transaction returns? Why would we want to do it later?
No, not later. Just the good timing to get when the request is served. I think we just need to get notified when the request
is committed. We need to know when it's
committed. Yes,
that's it.
Committed.
That's just one future. The future we return represents when the commit is stable on disk, committed. That's it. Shouldn't need anything else.
Right.
Sorry, I don't quite follow. How do we know when the ordering of the ops
as soon as due transaction returns? That's it.
We cannot cut the corner because it's racing.
Okay.
No, there's no race. Why would there? Sorry, what?
Because we could fail when they send the transaction down to the object store. If it is raised by another one, so we need to wait until the due transaction returns.
No, that's not true. Hang on. Racing will not cause a transaction to fail. SeaStore internally will retry it.
Yes, that's also my understanding.
So that's not a problem. Failure isn't relevant here.
No, I didn't claim that it's a problem. I just want to emphasize that the inherent nature of the object store or SeaStore, we cannot assume that the ordering of the request.
Right, that's what I'm telling you. Yes, you can.
By sending the.
Yes, you can. When SeaStore accepts two transactions, they will be completed in that order.
What do you mean by accept? I think the ordering...
New transaction, the actual function call returns. That's it.
By returning, you mean return the future? And
no, I don't. I need the actual C call, the call stack frame exits. Because SeaStore internally maintains its own pipeline. And will ensure that everything proceeds in order. So as soon as due transaction, the literal function call literally returns a future, that's it. It's already ordered. You do not need an additional callback.
So we don't need to wait until the realization of the future returned by due transaction?
No, and it's specifically designed so you don't have to. If you submit 10 IOs to SeaStore in a row, the futures for them will resolve one at a time in the same order in which they were submitted.
Even better, so we don't need to wait for
SeaStore should be doing the same thing. If it's not, there's a bug.
Okay, I see.
We really, really don't want to be introducing another callback here. It doesn't make things simpler. It creates exactly the same problem, just later.
Okay. Now I understand.
In general, that's how we want interfaces to work. When interfaces make promises about ordering, this is what that looks like. It's precisely no different from calling into queue transaction in classic OSD. There isn't a callback that indicates when the operation is ordered. When queue transaction completes, that's when the operation is ordered. It will be sometime later before the callback resolves, but that's immaterial to the ordering.
Okay.
Futures are not, in this sense, different from callbacks at all.
We are safe.
Yep. I mean, it may be buggy, but that's the goal. Like, SeaStore's responsibility is to ensure that this is true.
Anything else? Nope. Okay, talk to you later and have a good one. Thank you.
Later.
See you.
Thank you. See you later. Bye.
Thanks all.
Bye.
See you.